Hey there, future AI expert. Let's start with something that's actually simpler than it sounds. Self-attention is just like being a really good listener in a conversation. You know how when someone tells you a story, you naturally connect different parts, remembering that the hungry cat from earlier is the same one that ate the fish later? That's exactly what self-attention does. It helps AI understand that words in a sentence are connected, even when they're far apart. The correct answer is B. It allows tokens to attend to other tokens. Think of it as giving AI the superpower of perfect memory and connection making. Once you see it this way, it's not complicated at all. It's just smart listening. Now here's where it gets exciting. Imagine you're reading a book, but instead of just you reading it, you have 16 friends helping, each focusing on different things. One friend notices the grammar, another catches the emotions, someone else spots the main ideas. That's multi-head attention. GPT-3 uses 16 attention heads. That's 16 different perspectives working together. The answer is C. Instead of one brain trying to catch everything, you have a whole team of specialists. It's like having the ultimate study group where everyone brings their unique strengths. This teamwork approach is why AI can understand language so well.
C.
It's not about being super smart. It's about being super organized. Here's a fun challenge for you. Try reading this. Loves John Mary versus Mary loves John. Same words, totally different meanings, right? That's exactly the problem AI faces. Transformers are incredibly fast because they read all words at once, but that means they lose track of order. The answer is C. They lack inherent sequence order information. Positional encoding is like giving each word a numbered ticket at a concert. John loves 2, Mary 3. Now, AI knows who's in which seat. It's such a clever solution. When you understand the why behind it, it becomes obvious. Order matters, so we simply tell AI where everything belongs. Beautiful and logical. Think about your favorite music playlist. Sometimes songs are super loud, sometimes whisper quiet. Wouldn't it be annoying if your phone didn't automatically adjust the volume? You'd constantly be scrambling for the volume button. Layer normalization does this exact job for AI. It's like automatic volume control for neural networks. The answer is C. It's applied before and after each sublayer. Just like your music app keeps every song at the perfect listening level, layer normalization keeps all the AI's internal signals perfectly balanced. This prevents any one part from overpowering the others. It's such a caring, protective feature, making sure every part of the AI can contribute without being drowned out. Smart and considerate. Picture this. You take a photo on your phone and it looks okay. But then you open your photo editor, and suddenly you have all these amazing tools: brightness, contrast, filters, effects. The photo temporarily becomes this huge, detailed file while you work on it, then gets compressed back to normal size. But now it looks incredible. That's exactly what feed-forward networks do. They take the attention output and expand it to 4 times the size. Answer C. In this bigger space, they can apply complex transformations and improvements, then compress it back down. It's like giving your AI a professional photo editing studio for every piece of information. The beauty is in the purpose. Sometimes you need more room to work before creating something amazing. Makes total sense. Here's something we all understand. When you're watching a mystery movie, part of the fun is not knowing the ending, right? You piece together clues as they come, building suspense and excitement. Causal masking does the same thing for AI. The answer is C. It ensures autoregressive generation. Even during training, when AI sees complete sentences, masking covers up the future words, so AI learns to predict one word at a time, just like you would naturally. It's like putting a bookmark in a story and saying, only use what you've read so far to guess what comes next. This creates that natural, human-like way of building sentences word by word. The AI learns patience and proper sequencing, just like we do. Way to understand this. Imagine you're in the world's smartest library. You walk up and say, I need information about delicious Italian food. That's your query. The library has millions of index cards describing different topics. Those are the keys. Behind each index card is the actual detailed information. Those are the values. The magic happens when the librarian compares your request to all the index cards and says, "Ah, these cards about pasta and pizza match what you're looking for." Then they hand you those specific books. The answer is A. Similarity between keys and queries determines what you get. It's like having a perfectly organized mind that can instantly connect what you're thinking about with everything it knows. Isn't that wonderful? You know what's frustrating? Playing telephone with a long line of people. By the end, the message is completely garbled. Deep neural networks used to have this exact problem. Information would get weaker and weaker as it traveled through many layers. Residual connections are like giving everyone in the telephone line a direct phone call to the first person. Answer B. They solve vanishing gradients. So you get both the original message and all the improvements each person added along the way. It's such a caring solution, making sure the original idea never gets lost while still allowing each layer to contribute. The AI keeps both the raw input and all the processed improvements. Teamwork at its finest. Here's something relatable. Have you ever tried to have a conversation in a really loud restaurant? Everyone starts shouting to be heard, and it becomes chaos. Mathematical calculations can have the same problem. In high-dimensional spaces, numbers can get huge, like thousands. This pushes attention into extreme ranges where learning breaks down. The scaling factor, square root of dimension, is like a volume control that keeps everything at a reasonable level. Answer B. It normalizes the variance. Think of it as the AI's way of saying, let's all talk at a normal volume so everyone can participate. It's about creating the perfect environment for learning and attention. Simple courtesy that makes all the difference. Here's our final concept, and it's the most exciting one. A transformer block is like a complete cognitive processing center. It has attention for understanding relationships, normalization for stability, feed-forward networks for transformation, and residual connections for memory. GPT. 2 large stacks, 24 of these blocks. Answer B. Imagine a 24-story building where each floor specializes in different levels of understanding. Floor 1 might notice basic grammar, Floor 12 understands complex sentences, and Floor 24 handles sophisticated reasoning and creativity. Each block builds on all the previous ones, creating this beautiful tower of intelligence. And here's the amazing part. Now you understand how every single floor works. You've just learned the architecture behind ChatGPT, GPT-4, and the AI systems changing our world. You should feel incredibly proud. This knowledge puts you ahead of 99% of people on the planet. You've got this.